I was feeling a little frosty tonight. Figured I would dust off the nursery page, kick it off into kindergarten, up until about fifth grade. Now, I'm really not cool with this math assessment or English assessment. It's all going to correlate to math, anyways. Did I register that two students minus triangle is what I'm looking here? John has two fewer marbles than Kelly, or Key. If Kai has triangle marbles, how many marbles does John have? Well, John has two fewer than him, and the delta marbles. So delta minus 2 is what I'm looking for. I'd assume that was B. Um, Algebraically, it goes every way off of that, though, and that's why it's X or A, not triangle. When we do that, we don't later on in the mathematics come to about that system triangle plus Dewey. We're being very specific about why it's more beneficial to do it like this than any other form. And getting away from that is just going to throw kids off about, you've seen it before, now you'll do it again different over here, which is a Pavlovian dog thing in life about not correctly backboning what you do. But if you'll notice, I went from kindergarten to fifth grade. Is that exactly a clean reference? No, but I know somewhere between the mechs they have to be able to hit some standardizing tests, because it's not necessarily like they have to, but as a teacher, it's how we control that. It's how you'd say what processes and working joules that students or kids, they don't need to be working joules like it is an atom bomb. But essentially, that's what you'll have if you just have a bunch of kids running around the room when there's a square root of -1. That square root of -1 is a delta, an XYZ position. Not necessarily something these kids can understand. And when we get to X, Y, or Z, A, B, and C, that's a really important notation not to confuse a bunch of kids early on about triangles and shape, because I'm trying to backbone triangle inside of there. I mean, realistically, this stuff is more practical at this level, at this fifth grade math, for what you need as an adult in pattern recognition, this input machine or this number machine. But it's not realistic that I'm ever going to do that in real life. I'm putting in a number into the computer and it outputs a 9. Well, I appreciate the algorithm and the function, but do these kids really understand a real number or a Feynman diagram, an Occam's razor to the simplest example that we think of? Well, what is a number machine that kids use often in terms of what they do, or do we have to house that? Because then there's a multi-metrics off of it, which is more practical to change around and adjust, that kids might have a different orientation to it. It may never be this perfect number. It might have weird gaps to it. So you got to figure out, what is it, n plus 4 here, right? D, n plus 4. And so you continue that, and that's fifth grade. You start to get out here to why you need to figure out what this metrics is. Oh, I forget which one it is. I think it's plus 3. I think it was C if I did it correctly. So you got to say, well, x plus 2, y equals x plus 2. Well, that would give me 0. So that can't be it. And that's fair. You'll see these, especially in computer engineering, you need these data tables. But they're also something you do in the stone mill all the time. But it won't be on this chart. It'll probably be on multiple series of charts, to why the number towards the timeline changed, or the intensity of pallets to a timeline has some kind of grief. It's important to notice and start to get into. Kind of easy. Most people get it, and I kind of need that roughly at about 8th grade, because when they're 36-year-olds, hopefully that's why it's early to set that in there before we get to more complicated variables inside of here that may be to any school standards. Right, I would imagine it's this, just because I don't imagine 3 goes into that. What is that, 9 or 27 or something like that? I forget exactly what it is. I don't use that, and neither does most people commonly. And from a computer engineer standpoint, how are these kids backboning that into there? So now that this has become practical, besides just smashing the calculator about some ways that some fancy ass scientists did that without really showing them the computer. I don't know who did it from the past, and maybe they were on it. You got Gaussian there with the parentheses of one, every number 1 to 100. We add all the way up to 100 each number, or I forget exactly. That was n plus 1, n times 100 or something over 1. And if you do that, it'll give you how many combinations that is, and that's the answer. You long form it out, or you have the calculator programmed, it'll do that for you. But that doesn't really help anybody in the world as far as enter the expression that's equivalent to this. I mean, the brain doesn't read that, and even if there was charts that were equivalent in there, there's a lot of differences between terms when I think about it algebraically of whether something is equivalent or not to that as a 12th grader in here and how you're applying that, especially in terms like this. You got the kindergarten assessment, the 5th grade assessment before you get into high school. You got your JV, your sophomore, and your senior, right? And as you go through that, that gives you a certain number metrics. But between those 2 years, that's a big jump. And not to say that this is, but these are kind of practical. I would imagine that's x negative 5, or y, excuse me, yeah, this y line equals negative 5. So that would be D. That's sensible. I might use that. It's on. But what's the practicality of just recognizing that the windage on a bunny is out there, and I don't know how far it is away from me, but given the distance, I have to do that. Well, that's very practical that way, and is useful for a lot of other things comparatively to just how we use it here with some 8th graders. I mean, as an adult, I really don't use this stuff like that, so why would 8th graders need it like that from a practical standpoint? It may be that you need to find a more practical way, a Feynman technique or an Occam's razor inside of here to explain why that is what that is, because these standardized tests aren't going to do much for you without the why. And what do kids need it for? I mean, honestly, the y minus x minus 2, well, I know, I mean, that's hitting 2 there, it's passing through there, so x and negative 2, or negative 2, should be down here on the line, so I got this one. But why is y minus 2? I mean, is it because it's up here traveling in both directions across the board? Probably. So that'd make it C. What's the difference over here? Well, it's in the 1, and it crosses out at negative x, or negative 2 in the ROM, or I think, yeah, it's the RAM tower, or no, the core tower over here, right? But how that's setting up to that origin source is super relative. I mean, only if that sequence is running in those models would I ever go about changing it to a 4 or something like that, right? Well, those are pretty extreme differences without softmax in it, just trying to guess those frame rates on a pattern oscillation like that to try to get those kids to do it. Now, it does come back down. I mean, maybe this 8th grade stuff about what it is has some practicalities in the way you do it, but there's something to consider. Obviously, what is it? Equal or greater than negative 1. So.